Hello and welcome to this video tutorial. In this video, we are going to learn about using Modbus driver with Infilink. We are going to use Modbus TCP/IP protocol for this video. Your typical Infilink project will have one or more Modbus devices connected to computer using Ethernet cable. Infilink Modbus driver will connect to those devices, gather the data and exchange that data with Infilink. We are going to use Modbus device simulator instead of actual Modbus device for this video. By using a simulator, we will be able to examine internal data of the Modbus device as it interacts with Modbus driver. Let's get started. For this video, I am having Modbus device simulator running on the left. On the right, Infilink is running and displaying data collected from Modbus device or simulator. We have Modbus driver working in the background. This driver is getting data from the simulator and sending it to Infilink. We can see that the data in the Modbus driver is arranged into channel and devices. We have channel 1 as the channel by which the data is getting collected. We have these 4 devices in that channel. We are getting data from holding registers, coils, inputs, and internal registers. We can see that we are getting holding registers data so the data from register 500 is getting here, which is tag 500. We can also see data from register holding register 502 is getting into tag 502. Similarly, we are getting the data from coils, inputs, internal registers, and holding registers. On Infilink window, we can see status of various coils or outputs. We can see that the coil 502 and coil 505 are continuously changing the status, and that is because the status of coil 502 and 505 are continuously changing in the simulator. We can toggle the coil status of coil 500. So I am highlighting coil 500 here and toggling the status of coil 500 by clicking this button. So we can see that the coil 500 has become 0 or off. We can switch it on again by clicking this button, and we now see that coil 500 has turned on. Similarly, I can change the status of coil 503. Currently it is on in the simulator. I am clicking this button and the status of coil 503 becomes 0. Let us now see holding registers displayed on Infilink window. We see that the values of register 500 to 507 are displayed in this portion of the window. These are word values or 16-bit values. We see that the register 500 has a value of 23,500 and something. We see that value here. Similarly, register 501 has value of 6666 and we see that value here. We can also see that the register value 505 is being displayed on a nice little gauge here, and with this slider we can change the value of register 505. Let's highlight register 505 here with the value of 6000. I slide the value of the slider and make it approximately 4000. So the gauge changes to show the value of about 4000, and we see that the simulator is now displaying the value of 3999. We can also write the value from infilling to driver by using data input animation. I will now try to change the value of register 501. Let me highlight the register 501 in the simulator. It has currently the value of 6666. So I click here and enter the value for register 501 as 3333 and hit OK. I see that the value has changed in Infilink window as well as in the simulator. Infilink can also display the 32-bit data or two 16-bit values of two consecutive registers. I am seeing here that values of two consecutive registers 509 and 5010 are combined by Infilink and displaying them as 32-bit data. So register 509 has a value of 4444 and register 5010 has a value of 0. If I change the value of register 510 and make it 1, the value of combined value of this quantity, this tag, becomes 69,980. Similarly, I can write 32-bit data here and the value of these two registers will change to reflect that data. So instead of 69,980, I am making it 80,345. We see that the value of this register has changed. Similarly, Infilink can handle floating point data, and for that Infilink uses two consecutive registers. Here we are using two consecutive registers 511 and 512 and treating the combined data of these two registers as a floating point value. We can see the value of 511 is 14,418 and register 512 has a value of 170,029. So by combining these two values and doing some clever math, that value is treated as a floating point value and that is displayed as 66.8899. I can change that floating point value and let me try the value of 6756.2367 and we'll observe that the value of register 511 and 512 will change. Infilling also allows to check the individual bits of the register and display the values of those registers as on or off. So here we are seeing the register 508 is displaying the binary value and the value of individual bits is read by Infilink, and you are seeing that the last bits are changing continuously and we are seeing that exact change here. I can stop the automatic increment of this register and you will see the bit pattern has stabilized. Now I can change the value of an individual bit. Let me set these two bits off. So first four bits are off and we should observe that change here. So I hit OK and we see that these 4 bits has become off. Similarly, I can switch off all the bits and we say that all the bits are displayed as off. Let us now see the values of internal registers. We are seeing that the values of internal register 2 and 5 are changing continuously because they are changing continuously in the simulator. Let me change the value of register 1 here and make it 4, 5, 6, 7, and we see that the value gets reflected in Infilling. We can also see the value of inputs and we are seeing the status bits. The inputs 500 is on, it's on here. Similarly, input 502 and 505 are continuously changing their status and we are seeing that in the simulator as well as in the Infilling window. So this is how we use Modbus driver with Infilling to get the data from the Modbus device or write the data to the Modbus device. So in the summary, we can read or write the status of coils. We can read the status of inputs. The values of registers we can access in various ways. One way is to access those values at 16-bit values. Then we can access those values at 32-bit values of two consecutive registers. We can access individual bits of the register and we can write the values to the registers for the holding registers. For internal registers, we can read the values of the registers. We can also check the values of individual bits of the individual registers. Now that we have seen how we can use Infilink and Modbus driver to interact with Modbus device, let's move ahead and understand how to set up Modbus driver project. But before getting to Modbus driver project, we are quickly going to understand about Modbus address space, Modbus driver channels and devices. When working with Modbus devices, we typically refer to outputs or coils, inputs, holding registers, and internal registers. Coils and inputs represent a single bit data having 0 or 1 or on and off as its values. Holding registers and internal registers are 16-bit values. Valid addresses for each of these types are listed here. Notice that addresses for coils start with 0. Addresses for inputs start with 1. Addresses for internal registers start with 3. And addresses for holding registers start with 4. We can also access individual bits of registers. To get the status of fifth bit of register 400100, we represent its address as 400 100.5. Valid bit numbers are from 1 to 16. You can connect multiple Modbus devices to Modbus driver. Devices can be configured to use different IP addresses. Modbus driver channel is associated with an unique IP address and port number. Multiple devices can be associated with a channel. Devices present on a channel will have unique device identification number. Maximum of such 10 channels can be used with this driver. Let us move ahead and create simple Modbus driver project and connect it to Infilling project. We are going to use this simulator to represent our Modbus device. This simulator is using local IP address 127.0.0.10 and port 502. Simulator includes 4 simulated devices. Let's go ahead and start our Modbus driver. Let us begin with creating a new project and a new channel. This driver supports TCP/IP protocol, so I am going to create a new TCP/IP channel. The default name is OK for me. The default IP address for this channel is 127.0.0.10 and port 502. These two values match with the IP address and port number of the simulator device which I am using. So these settings are OK for me. The other settings, these settings are somewhat advanced settings, and we are going to see the meaning or usage of these settings in the latter part of the video or in the next video. So currently I'm just hitting next and going ahead. These settings relate to the optimization for writing the values to the driver, and for these settings also I'm just going to accept the defaults and move ahead for now. So you will see my channel TCP channel 1 is created. So we'll now create a device for this channel. Click on the channel name, go to menu item device, new device. We are creating a TCP/IP channel and TCP/IP device. So the default name is TCP device 1. I change the device name to and move ahead. The device ID for this device I want to give as 4 because the device ID in the simulator for holding registers is 4. Hence I am using device ID as 4. I am going to accept defaults for these advanced settings. We'll see the meaning and usage of these settings in the next video. Just unchecking these two settings and moving ahead. Just moving ahead with the default values, and our device is created. Let's now start creating some tags for the device. I am highlighting the device name, tags, new tag. I want to read the value of register 500, so I give the name and the address as 400500. Remember that the holding register address has to start with 4. Holding register is a 16-bit or one word data entity, hence the data type word is very acceptable for me at this point of time, and client access of read write is also just OK for me. I hit OK and the tag is created. I'm going to create few more tags, so I press this button to create one more tag. I'm going to give name register 501 and address as 501. And to create more tags, I'm going to use little trick and hit this button repeatedly. So tag 501 is created, register 502 is created, register 503 is created, 504 is created, 505 is created. So in this way you can create multiple tag values quickly. So I have created these 8 tags with the addresses as shown here. Let's save and run the project. I go to File, Save. choose the location and give the project name as P3. Notice that the default extension for the Modbus driver file is DRX. I save the project and you will see that the full project path is displayed here. Let me maximize this window for a little time. You will see that the status bar also shows the project tags are 8 tags and the selected item tags are 8 tags, and the driver currently is in the configuration mode. Let me try to run this driver now. Put the driver in the run mode. So I click this button. I see that the driver has attempted to connect to that channel and IP address. The connection was success and we have started getting the values of those holding registers here. So if I put the driver and the simulator side by side, I see the value of register 500 is coming here. Register 501 is coming, as well as register 507 is coming here. So we have seen how a channel, device and tags are created for the Modbus driver. I am now going to stop this running driver and close this project and open a previously created driver project for this video. We see that this project has one channel and 4 devices. Let us see the channel details. Click channel name and hit key F4. I can see the channel properties in this way and I can also edit them. To edit or see the device properties, I highlight the device name and hit F4 key. I can now check all the device properties and I can also edit them. To edit a tag value, I just double click on the tag name and I can see and edit various properties of the tag. You will notice that we have used Boolean data type for coils and inputs. Coils and inputs are best represented by Boolean data type, which has value of either 0 or 1. We have used read-write as client access for coils because we can write the values to the coils. We have used read-only attribute, client access attribute for the inputs because we can only read the status of the coils. We are reading values of many holding registers. Please note that we are reading values of registers to 500 to 508 with a word data type. For register 508, we are also using various other data types. We are going to discuss various data types offered by Modbus driver later in this video. We are accessing status of individual bits of register 508 from bit number 1 to bit number 16. To access the bit number 2 of the registers, you will use the address something like 400.508.2. Let's check this tag 509 long. This tag has a long data type which is a 32-bit value and the address as 400.509. So this tag will read two consecutive registers from the Modbus device with address 509 and 510. Combine those values and present that value as a value of this tag. Similarly, this tag 509D word uses the data type as dword, which is a 32-bit value, and it will also combine the values of two consecutive registers. This tag 511 float has a float data type. This also will use values of two consecutive registers, combine them together, do a necessary conversion according to IEEE standard, and present that data as a floating point value. Let's now run this project and make sure that it communicates with the simulator and starts getting the data. So we see that the driver starts getting the data from the Modbus simulator. We are going to stop the driver and now turn our attention to Infilink to create a project and get the values of these tags into Infilink. We have already seen Infilink working with Modbus driver and getting the data from the Modbus device or simulator. Now let's start building the Infilink project to get the Modbus data into Infilink. I'm going to start design mode. Create a new project of Infilink. Give project a name. Just put a clock object in the corner. Change the colors a little bit. Okay, that looks nice. And save and make sure that everything is okay. So we are running the project, the clock is running, and we can now add further graphics to the Infilink design mode. To get the Modbus data, we need to set up the Modbus tags into Infilink. I go to tag groups and I need to create a Modbus tag group. So I click on this button, give a name to the tag group, give some description, hit OK. Now we'll get the register value of register 500 into Infilink. For that I create a tag and name that tag as T register 500. I need to tell Infilink which server item or the item from the driver is going to be associated with this tag. We switch to Modbus driver and see that we want to get the value of this tag 500 into Infilink. So for the server item, I need to enter channel 1 dot holding registers dot tag 500. I can type that entire thing manually, like channel 1 and dot device and something like that. But I am likely to make a mistake here, so I don't want to do that. I'll just go to this driver, select this tag and say copy tag to clipboard. What this does is it copies the entire fully qualified tag name into the clipboard. I come to server item and paste that clipboard value here. So you see I am getting channel 1 dot holding registers dot tag 500 as my server item set. I want to use word data type for the tag, and my tag creation is done. I have created one tag which is representing a Modbus driver tag. So I close this and save the project. I see the tag is listed here from the mod group. So I drag and drop. So by doing this, I am showing the value of this tag on the window. Let me save the project. I'm going to close the Modbus driver, and I will explain you the reason after some time. I run the project. You will notice that Infilling run mode has started. It has auto detected that the project uses Modbus tags, so it has started Modbus driver automatically. It loaded the last used project into the driver. It connected to the Modbus simulator. It started getting the values and start sending those values to Infilling, and we see that value coming here into Infilling. So our first quick purpose of getting a tag into Infilling is done. I'm going to stop the run mode, and you will notice that Modbus driver also automatically stopped running. I want to set up few more tags to get the status of the coils and status of inputs. So I need to know the server item names for those tags, and for that purpose I'm going to start the Modbus driver and load that project into Modbus driver. I'm going to switch back to Infilling design mode, go to tag groups, and in this mod group I want to create more tags. I want to get the status of this coil 500 into Infilling. So I'll have to create a tag for that coil 500. I will give a name tag coil 500, and again I want to get the server item name from the driver. For that I'm going to use the same trick which I used last time. Go to the driver, highlight the tag and say tag, copy tag to clipboard, or I can just press Ctrl C while this tag is selected. So I've selected the tag, press Ctrl C, and the fully qualified tag name is now put into clipboard. I switch to Infilling, highlight the server item field and press Ctrl V, and the fully qualified server item name is pasted in the driver tag. Now this is a coil, so I want to use a discrete data type which is just a 0 or 1 kind of data. I say OK, and my tag for coil 500 is created. Similarly, I am going to create a tag for reading the internal register. So I'm going to read the internal register value, which I will choose the value as register 2 so that I get a changing value. So I highlight this input register tag, press Ctrl C, come to Infilling, and in the server item field I paste that input register name, and I give a tag name tag input register 2. This is a 16-bit value, so I will like to use word data type and hit OK. So a tag to read that input register is created. I also want to get the status of an input. So I will choose an input which is changing continuously, and that input is 502. So I come to the driver, select the input 502, press Ctrl C to get that server item name, come to Infilink, create a tag, put that server item, and I'll say tag input 502. This is again a boolean value, so I'll choose the discrete data type and hit OK. So we have created one tag for reading the input register and two tags to represent two boolean values, one for coil and one for input. I close this dialog box and I want to create two indicators to represent two boolean values. I go to wizards and select this switch wizard, which I like to represent discrete values. So this switch I will like to show the value of the coil. So I select the tag, which is tag coil 500, and this will also act as an input. So when I click this switch, the status of the coil in the simulator or the device will change. So I'm happy with all these settings and I click OK. Similarly, I want to have one more switch or one more element like this to represent the value of the input status. So I have created this, hit F4 to see the properties, go for selection of the tag, and I select this tag input 502, and I cannot change the value of the input from Infilling, so I'll say treat this object as indicator so that I cannot change the value or write the value to the device. Hit apply and OK. My settings are done. I want to see the value of input register also. For that, I'm going to just drag and drop that value here. So I'm showing four different tag values on the Infilink window. Let's save the project. I need to stop the Modbus driver before running Infilink run mode. So I stop the Modbus driver and start running the project. You will notice again that run mode starts the Modbus driver. Modbus driver connects to the device and start getting the values and sending the values to the Infilink. I come back to Infilink and I see I am getting the value of tag register 500 as well as value of input register, and I am getting the changing input status of this coil. I have selected coil 500, which is on, and I can change the status of that coil by clicking this button. So now I go to simulator and I see the value of this particular bit is off. Let me arrange these windows side by side so that we can examine the things happening side by side. So I click this button and see the value of this particular coil being toggled. I am seeing the input status of this 502 here. I am seeing the holding register value of tag 500 here. I am seeing the value of 53,000 and the value of 12,000 because this is represented as signed number and this is unsigned number. So let me make this as unsigned number, and now we see the values match. I am seeing the input register value of this input and the value is 28,630. So in this way, we use Infilink to get the data from Modbus device using the Modbus driver. I want to show to you that how we can access individual bit values of the register. So let me stop the run mode. I will like to see the bit values of register 508. So I'm interested in now seeing the values of these tags 508-1, 508-2 and so on. These are the bit values of register 400508 from bit 1 to bit 16. So I switch to design mode, go for defining tags, and I want to add a Boolean tag. Go to driver, select this bit 1, press Ctrl C, come here, server item, paste the value and give the name tag 508 bit 1, and this is a discrete value, so I am applying this discrete data type. Hit apply, hit OK. I also want to have one more tag for this one more bit, so I'm just duplicate, come here, select another tag, hit Ctrl C, come to server item, paste it, and the tag is defined. I define one more tag, duplicate, come to driver, select one more bit, hit Ctrl C, server item, and done. So in this way I have defined three tags representing bit 1, 2 and 3 of register 508. So I close this dialog. Now I'm going to draw a rectangle and assign a change color animation to it based on the bit value. So I pressed F5, this animation dialog box has opened up. I select a change color and I want to change the interior color based on a discrete value, so I make these settings. I select the tag, which is tag 508 bit 1, and the colors I want is the green color for off and red color for on. So this particular object will represent bit 1. I'm going to duplicate this object by Ctrl D. One more time Ctrl D, and I'm just going to change the tags assigned to this object. So bit 2, bit 3. I can also highlight this, go to tags and select tag this way. OK and close. Let me just align these three items, space them nicely, and I'm done. So these are the three bits, and I'll just create a text object and say bits 1, 2 and 3 of register 508. Save the project, close the driver. Now you will notice that I am always closing the driver before starting the run mode, and Infilling run mode doesn't like that driver to be opened before it starts running. Hence I am doing this. I switch to run mode. Run mode starts. It launches the driver. The driver connects to the device, starts getting the values and sending them to Infilling. Now we see that these three bits, bit 1, 2 and 3 are off. Let's verify those bit values in the simulator, which these bits are 0, 0, 0. Now let me open up the run mode here and arrange it side by side. I'm going to change the bit values of this, and I see I have turned on this bit 1. Change the status of bit 0 so, or bit 1, the bit status changes. So folks, we have seen how Infilink and Modbus driver is used to get Modbus data from the Modbus devices. We have covered a lot of topics, learned a lot, but still we have not discussed about various detailed settings regarding channels and devices uh, which are used for optimization of data communication or data collection from the Modbus driver. We'll do that in the next video. Thanks for watching this video, and bye bye.